let me explain about the lane design, how lane work. Yeah. So put the headline, lane design, lane design. Yeah. So first lane design is the flat network. How flat network work? Suppose all switches are in the they are connected in the serially. Serially means suppose this is the one switch. Yeah, this is the other switch. They are connecting in the series, serially. In the series, they are connected. Yeah, the fourth switch, fifth switch. All switches are connected to serially. Yeah. Here are the computers. Switches are connected to the computers. So all switches are connected to the, all computers are connected to the switch. Yeah. These are the connected in the series. So what is the impact of these things? Yeah, if they are connected in the series. Yeah, suppose this is the switch one, this is the switch two, this is the switch three, this is the switch four, this is the switch five. Yeah, all switches are connected to serially. So is there an impact? Yeah, is there any impact? Yeah, if suppose switch one means if they are connected in series, in like Mumbai is Mumbai, lot of populations is there, and Mumbai there are the uh, the trains are connected via Herbal. There are three lines are there, A, B, C, for example. So if suppose three lines are not there, and suppose single line is there in all the Mumbai station, all the Mumbai are connected via single railway line. So if local train is going via single line, so what is the disadvantage? Yeah, suppose this is station one, switch is my station, station two, station three, station four, station five. So is there any impact? Yeah, lot of impact, because in the peak hours, middle of middle of the station, lot of load, lot of populations are there, lot of people are coming on the central station. Yeah. So what happen if station something goes wrong? Suppose some work is going on in the central station. So all railway line will be affected. Yeah. All Mumbai local lines will be affected. So suppose this is switch one, switch two, switch three, switch four. Suppose middle of switch have some, there is this switch goes down. Then this PC cannot communicate with this PC. Means this side PC cannot communicate with the other side of PC, because middle of switch is down, power off, or middle of cables will down. Then all communication will be blocked. So if one switch goes down, then whole network will be down. Yeah. If suppose one person like in the company, suppose manager is not coming, then team team will not work. This team won't work on that time. Yeah. So always manager put, it's a secondary manager over there. Yeah. Wherever manager go for holiday or leave, then manager uh, means other person will be act as a manager. Yeah. So team task will be not impacted, because manager is single point of failure. Single point of failure means if one switch goes down, one link goes down, then whole network will be down. That is called the single point of failure. So flat network disadvantage. What is the disadvantage of single point failure? Then first disadvantage, single point, single point of failure. Single point of failure. Failure. Yeah. Let me. Yeah. No issue. Single point of failure. Failure. Yeah. So single point of failure means one device goes down, then whole network down, or once link goes down, then whole network will be down. That is called the single point of failure. So this flat network, the disadvantage is that it's a single point of failure. One switch goes down or one link goes down, then whole network will be down. That is very critical. There is the no backup concept here. Yeah. So flat network, first disadvantage, single point of failure. And second disadvantage is that if suppose Mumbai having the single local line, so middle of station, lot of resource will be consumed. Yeah. Because they need a water, public need a electricity. Yeah. For public need many things, Wi-Fi connection, many things they needed in the station. If suppose middle of station, lot of Wi-Fi connection will be consumed, lot of water will be consumed. Yeah. So middle of station, lot of load is there. So similar like that, if PC1 want to communicate PCN, yeah. So these are coming via this link, this switch. These are coming via this switch, this link. Yeah. Means this side PC want to communicate with this side PC. So this switch, the frame going via this switch. So middle of switches, lot of frames are forwarding. Lot of frames are forwarding. That's why it's a CPU load and it's a memory load will be increased. CPU load, memory load will be increased. Yeah. And lot of traffic going this side, traffic going via this side, traffic going via this side. So the link utilization will be high. Bandwidth utilization will be high. Yeah. So bandwidth utilization will be utilization. Utilization will be high. Yeah. CPU utilization will be high. Memory utilization will be high. Middle of switches, lot of CPU, memory, bandwidth utilization will be high. In shortcut, the CPU utilization, memory utilization, bandwidth utilization. In the shortcut, that is called these are the network resources. Like in our house, water, electricity, these are our house resources. Without electricity, without water, we cannot live in our house. Similar like that, CPU, memory, bandwidth, these are the resources of the network. So network resource resource utilization utilization, these are called the network resource utilization. So network resource utilization will be high. That is the second disadvantage of the flat network if switches are connected via serially. And third disadvantage is that variable latency. What do you mean by latency? Latency means the source to destination. How much packet will take time from the source to destination? How much packet will take time? That time is called the latency. That time is called the delay. Yeah. Suppose any packet go via India to US, so it will take more time. Yeah. Time means latency. It will take more latency. If any packet going via Mumbai to Singapore, so Mumbai and Singapore are nearby, so it will take minimum latency. Yeah, minimum time. So that is called the latency or delay. Yeah. So if any packet go PCN want to communicate, suppose PCX. So PCN send traffic. This is the PCN. PCN send traffic to PCX. So this distance is minimum. So it will take minimum time. Yeah. Traffic going via switch. So it is go to switch 2 to switch 4 to PCX. So because these are the minimum distance. So due to minimum distance, so time will take minimum. And suppose PCN send traffic to PC1. So this traffic going via this all cross all the switches and then go to the PCN. So the distance is higher, so it will take higher latency. So in this network, latency are variable. For minimum distance, it will take minimum time. For longer distance, it will take longer time. Yeah. So latency is the variable. So the third advantage, latency is variable. Latency is variable. Latency or delay. Latency or delay are variable, and that is not good for any network. Yeah. Suppose I am accessing Facebook very quickly, and other person accessing Facebook very slow manner. So it's a latency is not good for the network. All the user get a same latency. That should be good network. Yeah. So latency is one of the parameter. Yeah. Latency should not be variable. So this is the third disadvantage. And the fourth disadvantage is that fourth disadvantage is that if if I want to increase my network, suppose my business is growing and I want to increase my network, so I put lot of switches in this side, lot of switches in this side. I want to expand my network. I want to extend my network. So what happen? Middle of switches, lot of loads are there. Lot of CPU and memory load will be there. So middle of switches will be down because due to CPU and memory load will be high. That's why middle of switches will be restarted. So if I'm extending my network, so my design is failed. Yeah. Suppose Mumbai is day by day increasing, and if single line is there, so east side, west side, if we are increasing the platforms, we increasing the stations. So middle of station, lot of load, lot of traffic is there. Similar like that, if number of switches, if I'm increasing, so middle of switches, lot of CPU and memory load will be increased. So that is the one of the problem. So my network will be fail. If I'm extending my network, so my network will be failed. That is called the unscalable. That is called the, if I'm extending my network and my network will be failed, that is called the unscalable. Unscalable. Unscalable means network will be failed. Suppose any ISP right now running 4G technology and they want to launch the 5G technology. So they are replacing their routers. They are replacing their media. So their 4G network is unscalable. If they are running in the 4G router, they are running the 5G technology. So their network is scalable. Scalable means if we are running the current technology, we are running the 5G technology over there, means my network is successful. My 4G network is successful to launch the 5G technology. So that is called the scalable network. And if network is failed, that is called the unscalable network. So if I'm extending my switch, if this side switch is increasing, this side switch is increasing, and my network will be failed, that is called the unscalable. Unscalable means network will be failed. Scalable means network will be successfully. So my network is unscalable. So that is the fourth disadvantage. So how does I solve this problem? How to solve this problem? So before solving this problem, I need to understand how many types of traffic flow. We need to understand the traffic flow. Yeah. So how many types of how how many types of packet forwarding, frame forwarding, frame forwarding. How many types of frame forwarding? So there are two types of frame forwarding. The first one is the PC to switch. PC to switch. I will use short form of the switch. So that is the switch. PC to switch. Yeah. Means my traffic going via PC to switch, PC to switch, PC to switch. Yeah. Switch to PC, PC to switch. Yeah. So the first traffic flow is PC to switch. Yeah. And this second traffic flow is the switch to switch. Means this switch sending traffic to this switch. This switch sending traffic to this switch. This switch sending traffic to this switch. Means the second traffic flow is the switch to switch. So second traffic flow is the switch to switch. Yeah. So I need to stop one of the traffic flow. I need to stop the one of the traffic flow. I cannot stop this switch to PC traffic because my PC need a internet. My PC need a network. So it should be connected via switch. Yeah. Then switch to PC or PC to switch. I cannot stop the traffic. It required because without connecting the switch, my PC cannot get the internet. So I cannot stop this forwarding. I cannot stop the switch to PC forwarding. Yeah, this should be needed. But I can stop this switch to switch forwarding. Yeah, switch to switch forwarding, I can stop this one. I can stop this one. Switch to switch forwarding, I can stop here. That is my problem. Means I can resolve that problem if I'm stopping switch to switch forwarding. Yeah. Let me draw because the in board I don't have too much space. So let me erase this diagram and let me draw other diagram here. So need to stop the switch to switch forwarding means I cannot connect these switches. Yeah. This is the switch. This is the switch. This is the switch. This is the switch. Yeah. So I remove this switch to switch forwarding. So how PC1 want to communicate? This is the PC1. This is the PC2. This is the PCN. N. This is the PCX. Yeah. So how this side PC communicate with the other side of PC? Yeah. So I need a one of these centralized switch. Yeah, centralized switch. I need to connect one of the centralized switch. Centralized switch. This switch is the high horsepower. What do you mean by horsepower? Horsepower means horsepower. Horsepower means not elephant power. Yeah, it's a horsepower. Yeah, horse perform the lot of work. Yeah, its efficiency are very good. Horse efficiency. Horse horse efficiency are means working working like he can or they can work a lot of. Yeah, but elephant not doing lot of efficiency. Their stamina, their efficiency are very minimum as compared to horse. That's why it is called the horsepower. Yeah. So as compared to these switches, this switch have the lot of horsepower. Horsepower. Yeah. Horsepower means this efficiency as compared to CPU and memory, everything. This switch have the lot of CPU and memory. Yeah. Their horsepower is very good of this switch. Yeah. And these switches have the minimum horsepower. Yeah. So this centralized switch is the high horsepower. So I will connect the all the switches to this centralized switch. All the switches I will connect this switch. Yeah. So my problem will be resolved. How many types of problem resolved? CPU, memory, and bandwidth utilization will be high. This problem will be resolved. How it will resolve? Because this, as compared to these switches, this switch is the high horsepower. Yeah, it's a high memory and CPU, so they can process lot of lot of frames. They can process lot of frames will be processed by this switch. There is the no CPU and memory load will be high because it's a memory and CPU horsepower is high. So CPU and memory load will be means high this switch. So that problem will be solved because all the switches are communicate via this switch. If switch this PC want to communicate this PC, so this switch will be processed. It's a centralized switch. So my CPU memory load problem will be resolved. And the third problem is latency is variable. What do you mean by latency is variable? Latency is variable in the flat network, but here is the latency is fixed. Suppose PCN want to communicate PCX, so traffic going to this centralized switch and this centralized switch forward that traffic to the switch 4. Yeah. And suppose switch PCN want to communicate with PC1, so this traffic go to this switch and this switch send traffic to the PC1. Yeah. So my latency will be fixed for this PC as well as this PC. Yeah. So latency is variable. That problem has been resolved. My latency is fixed now. And the third disadvantage, it's a flat network is unscalable. But now my network is scalable. If I'm connecting lot of switches from this switch, if I'm increasing my network, so this switch have high power, high efficiency, lot of CPU and memory in this switch. So I can extend my network. There is the no problem. So unscalability means if I'm extending the network, my design is successful. That is called the scalable. So unscalable problem has been resolved. Yeah. So my fourth problem has been resolved. Yeah. Unscalability problem has been resolved. So my three problem has been resolved. But my fourth problem is still continue. Yeah. My fourth problem is not resolved. My first problem is not resolved. Single point of failure. Because this switch goes down, then all network will be down. So single point of failure still exists. That problem is not resolved, single point of failure. So I need to solve this problem. So I need to take a backup. Backup means redundancy. Yeah, redundancy. So this switch, I will take other switch, same capacity switch, same horsepower switch. Yeah, I will take other switch and I will connect the redundancy. I will connect the secondary cable here. Yeah, if one link goes down, then traffic goes via second link. So this same capacity of switch, other switch, I will connect here. Yeah. So both the switches having the same capacity, if one link goes down, so it will shift to other link. Yeah. So for link level, I have provide the redundancy. For the switch level, I have provide the redundancy. Redundancy means backup. Yeah. So if one switch goes down, then whole network will not goes down. Yeah. So single point of failure will be resolved. Resolved because these are the two switches. Yeah, this same capacity of switches I have connected. But the problem is that this same capacity of switches I have connected here, so they should communicate to each other. They should sync to each other. Yeah. How this switch say, how this, suppose PC1 want to communicate PCN, it is sending traffic to this switch. Then this switch forward the traffic to this switch or this switch. This switch, they are sending traffic because these are the different switches, same capacity of switches. So two switches combined together, physical, they are two switches, but I merge these two switches. Yeah, I can connect two different switches. That is called the staking. So they are synced together. So we need to connect one cable between these two switches. These two switches, I need to connect a single cable, a single or double cable for redundancy, because whatever configuration is here, same configuration will be here. Means this all the below switches, above switch show as a single switch. Yeah, like any person in the long distance, then two persons are there, but we are assuming these are the single person because there are a lot of distance are there from me to destination. So similar like that, this all the below switches, these showing this, these are the not two switches, these are the single switches. So that is called the staking, stake. That is called the stake. Yeah. To combine multiple physical switches into single switch, that is called the stake. Yeah. So there are two switches are there. They are so as a single switch. Yeah. So this concept is called this is the virtualization. And right now, virtualization is very famous in the cloud. Yeah. It means many places virtualization is there. Yeah. So here is the multiple switches converted into single switch. See, multiple physical switches logically convert into single switch. That is called the staking, and that virtualization concept name is the staking. Yeah. Yeah. So these two switches are converted into single switch, and this cable is called the stake cable. Stake cable. This cable name is stake cable. Yeah. Stake cable. Then two switches means stake cable, and this process is called the staking. Yeah. Staking. So the real time staking process are lot of times used. Yeah. And I will try to perform this lab in the packet tracer. I will try, if stake cable are available, then I will combine multiple switches into single switches. Yeah. That is called the staking. Yeah. So this cable is called the stake cable. Yeah. And the difference between these switches have minimum CPU and memory, and these switches have the lot of memory and processor, lot of CPU and memory of these switches. So these switches are name is different, and this switches name is different. These are accessing the network. These are accessing the switches. Sorry, these are accessing the PCs. These are accessing the host. Yeah. So that's why these switches, the below switches, all the below switches, all the like switch 1, switch 2, switch 3, switch 4, all below switches is called the access switch. All below switches are called the access switch. And these switches have lot of memory, lot of processor. So these switches is called the distribution switches. Distri, distribution, distribution switches, distribution switches. And these switches is called the access switches. Yeah. And these switches are connecting to the PC. These switches are connecting to the PC. So this link are connecting to the PCs. So all link which is connected to the PC from the switch to PC. So that link is called the access link. Access link. All the link is called the access link. Yeah. So all link are called the access link. And all the access switches are connected to the distribution switches. Yeah. So this link is called the this link is called the uplink. 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 Uplink means access switches are connected to the distribution switches. So all link called all link is called the uplink. Yeah, uplink. And this port, yeah, like those are connected to the PC. All the port, those are connected to the PC. Yeah, this port is called the access port. This port is called the access port. Those are connecting to the PC. And this port between the switch to switch port, yeah, those are connecting to the my uplink switches, my distribution switches. This all the port, those are connecting my distribution switches. This port is called the uplink port. Uplink port. Port. Uplink port. Yeah. This port is called the uplink port. Yeah. So these are the naming convention of the access link, access port, yeah, distribution layer switch, access layer switch, yeah. So these are the architecture of the one office, yeah, one office. This architecture for the dedicated to the one office. Similar architecture for the all the offices, similar architecture. So let me draw the architecture for different offices. So suppose this let me erase this one. Suppose there are four offices are there. Suppose this is the this is the Mumbai office, Mumbai India office. Here are the distribution layer switch, sorry, distribution switches are connected to the access switches. Lot of switches are there. Yeah. This is distribution switches. This is the access switches. Access switches are connected to the PCs. All the PCs are connected here. That, that is the Mumbai office in India. This is the Mumbai office here. Same office, suppose in the US, or suppose in the Pune. Pune is one of the city in India. Pune. Same architecture. This is the my distribution switches, and distribution switches are connected to the access switches. Access switches. So this is my Pune office. Yeah. And suppose let me draw not Pune. Let me Bangalore. Bangalore. Bengaluru. That is the Bangalore. Yeah. And the same office in Delhi. Delhi. Yeah. These are the distribution switches. These are the access switches. Yeah. Same architecture is there here. Yeah. Not here. Same architecture for the Delhi office. Yeah. And the same architecture suppose for the Kolkata. 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 Kolkata office is there. Same distribution switches are there. All the distribution switches are connected to the access switches. All are connected to each other. Yeah, Kolkata office. Yeah. When all four offices are want to communicate to each other, my all four offices are connected to each other. So I need a one centralized communication point, one centralized office. I need to connect one centralized office. So suppose centralized office in Pune. It is middle of the India, Pune, Pune. There are lot of means there are high horsepower switches are there. They are connected to stake cable. Yeah, they are staking together. Yeah, and there are lot of as compared to distribution switches, all the distribution switches, this horsepower is very high. So all offices connected to centralized office. All offices are connected to this centralized office, huh? Pune office. Yeah. So as compared to distribution switches, their memory and processor is very high. So that's why this switch name is called the core switch. This switches is called the core switch, or like our whole body are connected via our backbone. Without backbone, our body is not communicate. So similar like that, this all this means these switches are connecting all the offices. So that switches is also called the backbone switches. Back backbone backbone switches. This switches is called the backbone switches because it's having the lot of memory and processor. They are having lot of memory and processor. So this is called the core switches or backbone switches. So how architecture are connected, how these switches are connected to each other. So core switches are connected to the distribution switches. Distribution switches connected to the access switches. So in the interview, they are asking the like switching layers. They are saying this kind of question. Switching layers are they are saying architecture of the network. So every architecture is similar like that, and they are follow the layers. Yeah, these layers. Let me explain. These layers in the top my core layer is there. Yeah, in top my core switches are there. So core switches are there. So that is called the core layer. Core layer. Core layer, my core switches are situated over there. Yeah. And then my distribution switches are there. So that is called the distribution layer. That is called the layer. And then finally, in the last, my access switches are connected. So that is called the access layer. Access layer. So there are three layers. Yeah. One is the access layer, the upper one is distribution layer, and the top one is the core layer. So there are three layers, and all the architecture in the network, they are designed on the same basis. Yeah. If you go through the all company architecture, so all architecture based on this layers, these layers. Yeah. The below one access layer, distribution layer are core layer, not a switch. This is not concept of the switch. It is concept of like ISP architecture where routers are there, lot of routers are there. So same concept they are designed here. In any ISP or any company architecture, they are based on this architecture. Access above the access, distribution, and up the distribution means above the distribution core layer. So there are three layers architecture. This is called the three-layer architecture. Yeah. Every company follow this. Sometime our architecture is minimum in office. We don't need a means like this kind of concept. So these switches are there. Two switches and two switches are connected to access switches. So these two switches are in the office in our general language. They are called the core layer switch, core switch. Yeah. But actually these are the distribution switches. Yeah, so there are this architecture is there. So that is called the hierarchical architecture. Yeah, hierarchical. So these are the lane design. Yeah. So in the next lecture, I will start the different topic like VTP. Yeah. So next lecture, I will teach you about VTP. Then we will go ahead STP in other topic. Yeah. So let me stop this recording.